It's springtime in Paris, and we are at the MPLS+SDN+NFV World Congress organized by Upperside. EANTC has staged another round of our annual multi-vendor MPLS and SDN interoperability event, this time with outstanding support from 19 participating vendors. More than 70 engineers came together in our lab in Berlin for 2 weeks of in-depth hot staging to cover all of the topics of innovations and new technologies in the SDN area this year. We have covered segment routing, we've covered Ethernet VPNs, we've covered path computation element protocol, we've covered netconf and YANG, and these are all the building blocks for the next generation SDN networks. In all of these areas, we've seen mature implementations that are advancing to the more complex scenarios beyond the basics that we've tested in the past years.
In the SDN test area, we want to show a big picture of service provisioning from different levels like LSP setup, the Layer 2, Layer 3 service provisioning, and managed traffic engineering. The goal of these tests was aimed to show the readiness of multi-vendor implementations in end-to-end service delivery towards service providers. We use a test setup at where all implementations of 8 different vendors sit in a centralized network management to show interworking towards a network with up to 17 different device implementations. The tested features included among path computation, element protocol, netconf and YANG, also extended BGPs. The examples address the segment routing policies, the egress peer engineering to increase the efficiency on the egress links of a cloud, and the BGP flow spec to apply ACLs in order to increase security of the network. We achieved a great interoperability in EVPN tests, achieving up to 16 features across IETF drafts, ITU-T, and MEF standards. Our vision of these EVPN tests was to show the majority of EVPN technology in end-to-end service delivery across scalable VXLAN data centers, MPLS data centers, and in-carrier Ethernet support. Among the tested features, like active-active multi-homing with integrated subnet bridging, we also had new features, the loop protection and the flexible cross-connect. In the segment routing transport network, we built not only the MPLS-based data plane, but also the IPv6-based data plane. The highlights of the tested features included protected Layer 3 VPN services with topology-independent loop-free alternative. The out-of-service time was under 50 milliseconds. 2 main technologies dominated in the access network of the overall interoperability tests, the microwave and the clock synchronization. We verified the Layer 3 VPN services across IP MPLS-based microwave, the bandwidth notification, and the service protection in this technology. In the clock synchronization, we verified the implementation of the ITU-T G8172 standard with the class 6 accuracy. The advantage of this implementation is about 260 nanoseconds time accuracy. The goal of these features was to show readiness of 5G for the mobile facilities.
It is very reassuring to see that the participating vendors supported multi-vendor interoperable implementations based on IETF standards even more than in previous years. So we're seeing that all the industries coming together on these standards and is on the way of deploying multi-vendor mature SDN scenarios. The EANTC team is on track to continue helping vendors to evolve and mature their multi-vendor readiness of their SDN implementations. So next year in 2020, we will again be here in Paris, focusing on even more SDN scenarios, focusing specifically on 5G readiness and everything it takes to get the next generation transport network going.